Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. Live lesson, A-level maths, year 2, pure. A-level, UK A-level book. It's chapter 5, example 7. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Let's start with a circle, and this is just a GCSE formula. So we've got the center here, and we've got the radius of, let's say, r. Just call the radius r. How would we work out the circumference of that circle? We use the formula circumference is equal to 2 times pi r. 2 times pi times r. Now we want to just take a piece of that circle and we want to make an arc in between. So let's take a piece. Remember that both black lines, they go from the center, so they're both going to be the same length. And if one is r, the other one's going to be r. And then what we now want is just the piece, just the arc around the outside. So let's make a arc around the outside. And now we just want the length of this pink arc. How did we make that arc? We took a piece from the circle. How big was the piece? Well, let's mark the angle as theta. So we've got an angle here of theta degrees. And we want to know how long is that arc? So we go back to the full circle and we say if it was a full circle, then the full circle has a length of 2 times. So the full circle, let me just check the sound is working. So the full circle has a length of 2 times pi times r. But now we've got just a fraction of the full circle. If we can just add on a times by a fraction, then we'll have our answer. Now, what fraction of the circle do we have? We know the full circle at the center has an angle of 360 degrees. So we could write 360 degrees at the bottom of the fraction. And this piece that we've cut, that has an angle of theta. So there's our fraction. So we can just take theta over 360 as a fraction and times that by 2 pi r, the full circle, and that would give us the length of this pink arc, which is called L. So I can replace L with C. I'll replace the C with L. So the length of the arc is equal to 2 times pi times r times theta over 360. But this chapter is a chapter on radians. It's a new way of measuring angles. So the 360 degrees, that was before we learned about radians. Now we know about radians, we can replace the 360 degrees with 2 pi, which is the same angle, but it's just another way of measuring it using pi. So 2 pi can be replaced, can go over the 360 degrees. And then what we notice is that we've got pi on the top and pi on the bottom, which means that we can simplify our formula. We can cancel out the pi, leaving a slightly shorter formula, but then we see we've got 2 on the top and 2 on the bottom, so we can even cancel out the 2's. So all we're left with is r times theta as our formula. And in algebra, we don't normally write the times sign, so we can just write it as r theta. So that would tell you the length of any arc in a circle, as long as you know the angle in the middle, and you're measuring that angle in radians, not degrees. This short formula would not work if it was degrees. If it was degrees, you'd have to use the full formula, which is starting with the circle formula, 2 pi r, and then timesing that by the fraction that you've got, theta over 360, just in case you ever need it for degrees. But now we'll stick with radians. So let's do an example with radians. So this one is in words. The question is, find the length of the arc of a circle with radius 5.2 centimeters and the angle in the center is equal to 0.8 radians. So because it's in radians, we can go ahead and use the very short formula. So the formula is L equals R times theta. We're going to use 5.2 as our R, and we're going to use 0.8 radians as our angle. So all I need to do to work out the length of this arc is R times theta, R times theta, which in this case, the radius is 5.2, that's the R, and the theta is 0.8. So 5.2 times 0.8, and that gives you 4.